Okay, class, we're starting 1.12, finding all real and complex zeros of higher order polynomials. We now turn to the problem of solving equations containing polynomials. We begin by getting the equation equal to 0, so the problem becomes equivalent to the problem of finding the zeros of the polynomial. So we have number 1, factorable polynomials. If we can factor the polynomial into linear and quadratic factors, we will be able to set each factor equal to 0 separately and solve, since we know how to solve all linear and quadratic equations. We got some experience doing this in section 1.11, but here are a few more. Now, we have 3x cubed plus 3x squared equals 5x plus 5. Now, what is the first thing that we should do? In this case, typically we would do the greatest common factor first. But even before that, we have to get everything, all of the variables and constants on one side equal to 0. So we have to do that first. And what we do, we find the variable that has the highest exponent, which would be our degree. So we find that variable and move everything over to that side. So we're going to subtract 5x and subtract 5 from both sides of the equation. So we will have 3x cubed plus 3x squared minus 5x minus 5 equals 0. Now our next step, which is what you said, that we have to look for the greatest common factor. The only greatest common factor we have here is positive 1, so we don't need to take that out. So now, since we have 4 terms here, we can group and see if we can factor. We group the first 2 terms, we can factor out a 3x squared, and we will be left with x plus 1. We group the second 2 terms. Now, since the first term of the second 2 terms is negative, whatever we factor out must be negative. So their greatest common factor here would be negative 5, and that would leave us x plus 1, and it equals 0. Now, we'll rewrite this in 2 parentheses. So we have 3x squared minus 5 times x plus 1, and that equals 0. Now we have factored this out. Now we can set both of our parentheses equal to 0. So we will have 3x squared minus 5 equals 0, and x plus 1 equals 0. So, we can add 5 to both sides. We have 3x squared equals 5. Now, I did not leave enough room here, so I'm going to take this here. So we have 3x squared is equal to 5. We divide each side by 3. We have x squared is equal to 5/3. Now we have to get rid of this exponent, the square off of the x. So we would take the square root of both sides. So this would be plus or minus the square root of 5/3. And this would be x is equal to. Now, here's one issue here. We know that our 3 in our denominator is not a perfect square. So we know we're going to have to rationalize the denominator. So we will rewrite this as the square root of 5 over the square root of 3. What will we need to multiply by in order to get rid of the square root of 3?
Square root of 3.
Right. We'll multiply the numerator and denominator by the square root of 3. So this would be x is equal to plus or minus the square root of 15 all over 3. Because we know the square root of 3 times square root of 3 is the square root of 9, which is just 3. Now that took care of this first equation. The second equation, we would subtract 1 on both sides, and x equals negative 1. So our zeros would be x equals negative 1, comma, positive or negative, square root of 15 all over 3. So in this case, we have 3 answers, and our degree is 3. So we are in line with our degree. Were there any questions from problem number 1? Okay. Problem number 2. we have x to the 4 plus 7x squared minus 18 equals 0. Now this is really nice. All of the values are on one side equal to 0. But if you notice here, we have not learned how to factor with x to the 4th. We did learn how to substitute in this situation. What would we do in this situation? Yes?
U equals x squared.
Right, we would use u. So we would make, well, let me do this so these won't get confused. So we'll take u and make it equal x squared. Now one of the tricks with u is when you have a trinomial, typically your u is going to equal to the middle term when it's going in descendant order, the variable of the middle term. So it'd be u equals x squared, so we would substitute. We would have u squared plus 7u minus 18 equals 0. Now, since we've been through factoring countless times, we will factor this out to be u plus 9 and u minus 2. U plus 9 times u minus 2. Now that we have this, we will substitute back in the x squared. So we have x squared plus 9 and x squared minus 2, and that equals 0. So now we would set both of these values equal to 0. So we would take x squared plus 9 equals 0, and off to the side we're going to take x squared minus 2 equals 0. Alright, so we would subtract 9 on both sides, and x squared is equal to negative 9. Now we would take the square root of both sides, the square root of x squared, and the positive and negative of the square root of negative 9. Let me write that down here. Square root of x squared equals positive or negative square root of negative 9. So the square root of x squared is x. The positive negative square root of negative 9 will give you plus or minus 3i. Now the x squared minus 2, we will add 2 on both sides. X squared is equal to 2. We'll take the square root of both sides. So we have positive or negative square root of 2 and the square root of x squared. So it would be x equals positive or negative square root of 2. So our final answer would be x is equal to plus or minus 3i, comma, plus or minus the square root of 2. And if you notice, our degree for number 2 is 4, and we have 4 answers here. So it lines up. Okay, now, we move on to page 99. Now this is more practice. So now we have x cubed plus 27 is equal to 0. Now, we first see that all of the terms are on one side equal to 0. Next we check and see if they have a greatest common factor. The greatest common factor is just positive 1. But now we look at the terms that we're given. What is x cubed plus 27? What type of equation or what type of expression is that, the x cubed plus 27? Yes?
The addition of cubes.
The addition of cubes. Both of these are perfect cubes. So, we would take this x cubed plus 27 equals 0. If we put this under a cube root, the cube root of x cubed is x, the cube root of 27 is 3. So it's the addition of cubes. So we know we would do a parenthesis that will contain a binomial and a parenthesis that will contain a trinomial. Now, to get the parenthesis, the answer for the parenthesis that contains the binomial, we'll take the cube root of x cubed, which gives us x, and the cube root of a positive 27, which will give us a positive 3. Now that took care of the binomial part of this factorization. Now we're going to do the trinomial portion. Now this is what happens. This parenthesis here, you could do division with the original left side of this equation. So you would do x cubed divided by x. That would give you the first term, which would be x squared. And then to get the last term, you would take positive 27 divided by positive 3, which would give you positive 9. Now to get the middle term, you'll look at this first parenthesis and multiply both terms by each other. 3 times x is 3x, and take its opposite. So it'll be a minus 3x. Now, one thing that you have to bear in mind when you're going through to solve for the zeros. Well, let me ask you all this. With that second parenthesis, the trinomial, what do you notice when you're doing the addition of cubes or subtraction of cubes with the trinomial portion? You say you could factor it out? Okay, it's actually the opposite. When you take out all your greatest common factor and you do the addition or subtraction of cubes, that second parenthesis you cannot factor. So that will save you time, especially when you're taking an exam. You know you cannot factor that, so you know you would immediately use what to get the zero? The quadratic formula. So we would do x plus 3 equals 0. We'll subtract 3 on both sides, and x equals negative 3. So we know negative 3 is one of our answers. But because we know we cannot factor this, we know we will use the quadratic formula. So what I'm going to do here, I want to list our A, B, and C. Our A is 1, our B is negative 3, and our C is 9. Now we could go off to the side and do the quadratic formula. So we could have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we would substitute. It would be the opposite of negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 times 9 all over 2 times 1. So we will have x is equal to the opposite of negative 3 is 3 plus or minus the square root of negative 3 in parentheses squared is 9. Negative 4 times 1 is negative 4 times 9 will give us a minus 36 all over 2. So this will give us x equals 3 plus or minus the square root of 9 minus 36 is a negative 27. And that's divided by 2. Now, with that negative 27, we know we could pull out an I. But the highest perfect square in 27 is 9. So it'll be I times the square root of 9 times the square root of 3, all over 2. So this will end up being x equals 3 plus or minus 3i square root 3, all over 2. So now our final answer would be x is equal to negative 3, comma 3 plus or minus 3i square root 3 all over 2. And if you notice here, we do have 3 answers, which is according to our degree. Now, in 111, when we got the imaginary number answer or the complex number answer, we did not include that when we were talking about the x-intercepts and everything like that, but we're talking about zeros here. When you do zeros, you include those imaginary complex numbers. Does everyone follow that? All right, so number 4. We have 2x cubed times x plus 3 equals 3x squared. Now, with this problem, we subtract 3x squared on both sides. So we have 2x cubed times x plus 3 minus 3x squared equals 0. Now we multiply. This would be 2x to the 4 plus 6x cubed minus 3x squared equals 0. Now, we look at all three of these terms. They do have an x squared in common, so we can factor out an x squared, and we add 2x squared plus 6x minus 3 equals 0. Now, we could take x squared equals 0, and then for this problem here, it is 2x squared plus 6x minus 3 equals 0. So we know this is going to end up giving us, if we take the square root of both sides, we don't put a plus or minus on 0 because 0 is not positive or negative. So this would be x is equal to 0, but it would be multiplicity 2. Does everyone follow that? All right, now, with this next problem here, if we listed our A, B, and C and multiply A and C, wouldn't that give us negative 6? Can you think of two terms multiplied together that would give you negative 6? Well, I'm sorry, factors. Can you think of two factors multiplied together that would give you negative 6, but added together would give you 6? Well, let's take a look at that. We take negative 6. The factors of 6 are 1 and 6 and 2 and 3. Those are all the factors of 6. If we make the smaller numbers negative, this will give us positive 5 and also positive 1, right? If we make the larger factors negative, that would give us negative 5 and negative 1. So that lets us know that this cannot be factored. Does everyone follow that? So, what we would do is list our A, B, and C. Our A is 2, our B is 6, and our C is negative 3. So now, we will go over here and do the quadratic formula, which we listed up here. And you can copy this in your notes. And so now, we're going to substitute. So we would have x is equal to the opposite of 6 plus or minus the square root of 6 squared minus 4 times 2 times negative 3. All over 2 times 2. So we have x is equal to negative 6 plus or minus the square root of 36, and negative 4 times 2 is negative 8 times negative 3 is positive 24, all over 4. So this would be x is equal to negative 6 plus or minus the square root of 60, all over 4. Now, the highest perfect square in 60 is 4. So it would be x is equal to negative 6 plus or minus the square root of 4 times the square root of 15, all over 4. Now the square root of 4, we know is 2. So it would be negative 6 plus or minus 2 square root 15, all over 4. Now if we look at all of these terms here, you notice that all three of these have 2 in common. So we could divide all 3 by 2, and that would give us negative 3 plus or minus the square root of 15 all over 2. So our final answer would be x equals 0, and is multiplicity 2, comma negative 3 plus or minus the square root of 15 all over 2. Now, one thing I want to stress to you all is this here. When you're taking a test, you do not write down that it's multiplicity 2, unless the directions ask you that. This is just letting you know that you have 2 here and 2 here, which adds up to the 4, which is the degree of our equation. Does everyone follow that? So, you don't have to write the multiplicity 2 unless you're asked. Okay, so now, we go over here to page 100. We finally made the triple digits. So now, it says, did you notice the same connection between the degree of the polynomial and the number of solution zeros you found as we observed in the previous section. We are now ready to state these results in a formal mathematical way called a theorem. Now, it's the fundamental theorem of algebra. A polynomial function of degree n has exactly n zeros counted with multiplicity. Okay, I want to go back to this statement. I actually kind of glossed over this statement, but it says that we notice the same connection between the degree of the polynomial and the number of solutions. Yes, there was a connection. Yes, if we count multiplicity. There is a connection if we count multiplicity. Does everyone follow that? All right, now, the fundamental theorem of algebra, polynomial function of degree n has exactly n zeros counted with multiplicity, which is what we stated earlier. Now, it says find irrational zeros. When you cannot factor the original polynomial, as long as our polynomial can be factored into linear and quadratic factors, we can find all the zeros. But what if we cannot factor? There is one more theorem that can sometimes help us find the zeros. The rational zeros theorem. If the polynomial function, which we see here is all the way from a(n) to the x to the n, all the way to a0, where all coefficients are integers, has a rational zero r equals p over q, then p is a factor of a0 and q is a factor of a of n. Now, the first thing is we need to determine a couple key words here. One of the key words that was stated was the word integer, a0, and a sub n. Does everyone know what an integer is? The whole number part is part of it. Okay, now listen. Sometimes, on some occasions, I will give you a definition that is technically not mathematically correct, but it's more practical. Does everyone follow that? And I will explain why it's not mathematically correct and why it's practical. Integers are basically positive and negative whole numbers and zero. Does everyone follow that? So that lets you know that if you have a positive, negative number, or zero, there could be no decimals, no fractions. Everyone follow that? Now, the reason why my definition is not mathematically sound is because whole numbers cannot be negative. And didn't you hear me say positive and negative whole numbers? Whole numbers cannot be negative, but to me that gives you a basis of what you're looking for. You know with a whole number you don't have a decimal or a fraction. So does everyone follow that? So when we're looking for this, we know that we're going to have a negative number, zero, and a positive number that will not have decimals or fractions with it. That's number one. A0. We learned earlier on with A0 that A0 means the constant. So when we look here with P, P is actually your constant of the equation. And then the A of n, if you look at this function here, A of n is actually the lead coefficient. And we know the lead coefficient is always connected to the variable with the highest exponent. So whatever that coefficient is with the variable with the highest exponent, that is what we would use for Q. Does everyone follow that? And we would get all of their factors. So now, this theorem allows us to identify potential rational zeros, P divided by Q. But we would still have to test these candidates to see which ones work. To do so, we need to substitute each candidate into f of x. if the value is a true zero of the function, the result should be 0. To make it faster and easier to test the potential zeros, we can make use of the calculator's table feature, which I will show you pretty soon. So now, we need to go on to page 101. Now it says, list all possible rational zeros as identified by the rational zeros theorem and test them using the calculator's table feature to see which are true zeros of the polynomial. Okay, now I will tell you this. In this first problem, I am going to go step by step as far as what you need to do. But in the following problems, well actually I would say these first two problems, I'll go through every step. But the following problems, we're going to skip a couple steps. Does everyone follow that? So if you have any questions on any step that I cover, please let me know. Okay, now, we look here at this function. We have x cubed plus x squared minus 5x minus 2. First of all, we have all the variables and the number on one side and f of x on the other side, which we know typically we would make 0 when we're solving for the zeros. Now, this is in descending order. So this is what we would do. We would take our P and divide it by Q. Because if we tried to factor this is not going to factor out. So we could actually cut through that. We know that we would group the first two and factor out an x squared, but then we would factor out -1. It would not work. So now, P is equal to A naught, Q is equal to A of n. A naught is -2. A of n, what is A of n? It's +1, like you said. Okay, so now, we have -2 divided by 1. You do not divide them. Remember, we're just trying to find the A naught and the A of n. So now we need to write the factors of both of these. The factors of -2 is positive and -1 and positive and -2. And the factors of 1 is positive and -1. Does everyone follow that? Okay, now, we have to divide out all of these values. So, we could take +1 divided by +1, -1 divided by +1, and then we could take, now what I'm going to do, there's going to be some, how should I say, it's going to be a little repetition here, but I'm going to show you how to get past the repetition. Because remember, this is positive and -1 and positive and -1, right? So you know what, actually we don't have to do that. We'll just leave it as is. So now, we will have +2 divided by +1, and then we will have -2 divided by +1. So, this will equal to 1, -1, 2, and also -2. Now, off to the side, when I talk to you about repetition, remember this is positive or -1, and this is positive or -1, right? So we did 1 over 1 and -1 over 1. But shouldn't we also, and I'm just going to do this up here, shouldn't we also have done 1, +1 over -1, and then also -1 over -1, right? But the reason why we didn't do that is because isn't 1 divided by -1 -1? And then -1 divided by -1 is +1. So by doing that, we are avoiding writing all of this duplication. Does everyone follow that? All right. So now, these are the values. This is not the solution, but these are the values we're going to use in our calculator. Now, they told us to use this calculator feature. So let's go through and use this calculator feature. Now this may not, I'm just going to, this may not come out too good. Let me see if I can make this look a little better. No, it's too dark. Okay, maybe 8. Yeah, I think that's better. Okay, so now, what we need to do here is first go to our y equals and type in the equation that we were just working on. So we would type in x to the third power, then you have to hit the right arrow key for it to come down, and then we would do plus x squared minus 5x minus 2. Now, for this particular problem, we do not need to graph that. All we need to do first is to type in the equation. And we need to test is 1, -1, 2, and -2. Whichever one of them or ones of them will make this equation equal 0, that is what we're looking for. So first thing that you need to do, and I'm just saying in preparation for problems that require you to either deal with very large numbers or fractions, press second and then window. Okay, now, do you see where it says independent? And it says X. I need you to go to X and press enter. Now when you do that, you can go to the table now. Press second and graph. And then when you go to the table, you could type in these numbers. You would do 1, enter, -1, enter, 2, enter, and -2, enter. Now when you put in your X, it automatically gave you Y. Now what we're looking for is which one or ones of these X values will give you a 0 for Y. The only one that does that is 2, right? So your answer here would just be X is equal to 2. And that would be your final answer. Does everyone follow that? Okay, now, we're going to try this with the next problem. So, we're going to start this off the same way as we did the previous problem. We have P divided by Q. That equals to A naught over A sub n. A naught would be -8. A sub n would be 3. And again, this is in descending order. And we have all of the terms here on one side, and f of x is equal to this. So these are the numbers we're dealing with. And the factors, the factors would be positive and -1, positive and -2, positive and -4, and positive and -8. That would be the factors of 8. The factors of 3 are positive and -1 and positive and -3. Okay, now, our next step, we need to write out all of these factors. So what we could do just to shorten the process just a little bit, positive or -1 divided by positive or -1 will be positive or -1, right? And then positive or -1 divided by positive or -3 will be positive or -1/3. positive or negative 2 divided by positive or negative 1 is positive or negative 2. And positive or negative 2 divided by positive or negative 3 will be positive or negative 2/3. Positive or negative 4 divided by positive or negative 1, positive or negative 4. And then positive or negative 4 divided by positive or negative 3 is positive or negative 4/3. And then we come here, this would be positive or negative 8, and then positive or negative 8/3. Now if you look here, if we would have wrote this out, this would have gave us 1, 2, 3, 4, 5, 6, 7, 8. We'd have wrote out 16 numbers. Does everyone follow that? Now what we have to do as our next step, because we want to find out which of these actually work. So we go back to our calculator, and we go to y equals, clear this out, and we type in this equation. It'll be 3x, let me write it out. It'll be 3x to the 4th plus x cubed plus 10x squared plus 4x minus 8. Now, since we already have our calculator set where it acts the independent variable, we could just go to second and graph, and then we could start typing in these numbers. Now, we just so happen to have the 1 and negative 1. We notice that negative 1 works. So I'll put it here, x equals negative 1. We know that'll be one of our answers. 2 and negative 2 doesn't work. Now, we can go down and type in 1/3, and then also negative 1/3. Okay, 1/3 and negative 1/3 doesn't work. Then we could try 2/3. Now 2/3 work. And then we could try negative 2/3. That doesn't work. Then we could try 4. Then we could try negative 4. Neither one of those work. We could try 4/3. And then a negative 4/3. Then we could try 8. And then negative 8. And then finally we could try 8/3, and then a negative 8/3. All right. So the only values that work is negative 1 and 2/3, and that would be your final answer. Does everyone follow that? Now think about it. Think about this. If we were not using the calculators, you would have to go in by hand and put all those numbers in and see if they work. So it's a good thing we have these calculators. So that would have been a lot longer problem than what we had. Okay, now, for section 2, we have finding irrational or complex zeros. We're on page 102. Once we have found one rational zero r, we divide the polynomial by the associated factor x minus r, which results is a smaller polynomial to continue working with. It is fastest to use the process of synthetic division to do this. We continue this process until we get a quadratic, at which point we can find remaining zeros by factoring or by using the square root method or quadratic formula. Okay, now, we said all that to say that we're going to have a situation where we're not going to be able to just, like we did in the previous two problems, where we're just able to say, okay, it's negative 2. We're done. We're going to have a situation where we're going to have to solve to find these other values using synthetic division. So let's go through and do this. First of all, this cannot be factored. And if you notice, this number 1 is the same as this number 1 over here. So we did this in part. Does everyone follow that? So if we go back here, we know that we cannot factor this. We will have to do what we did before. Now, we will have our P over Q. Our P is -2. Our Q is 1. The factors are positive and -1, positive and -2, all over positive and -1. So when we divide this out, this will give us positive or -1 and positive or -2 is what we will be working with. Now, we already know that our answer was just x equals 2 when we did that. 2 is the only value that we got that would give us 0. But the problem with that is, what is our degree of this function or equation? Is what?
3.
It's 3. Our degree is 3. We only have one answer. Now, one answer is fine if it was multiplicity 3. But it's highly doubtful that this is a multiplicity 3 with x equals 2. Does everyone follow that? Okay, so now, this is what we would do. Remember we had that problem, and it's stated up here, x minus r. And then we notice when we had x minus r, and if we set that equal to 0, that would end up giving us x equals r. Does everyone follow that? So if we rewrote this, well, we'll get back to that. Let's first do synthetic division. Synthetic division, using this problem here, this answer here, we would do our division bar and put the 2 here. Now, we look here at these 4 terms. We have to list all 4 of their coefficients. So it'll be 1, 1, -5, and -2. Now, we have to leave a little space under here to write numbers under here, and then we'll draw a line. Now, with synthetic division, we always bring down the first number. So we'll take 2 times 1, which is 2, and 1 plus 2 is 3. Then we'll take 2 times 3 is 6, put that under the -5. -5 plus 6 is +1. 2 times 1 is 2, and -2 plus 2 is 0. Now listen, this last value here is always your remainder. And since we have a 0 remainder, that is great. So this makes this problem a lot easier. Now, when you write your answer from the synthetic division, these are coefficients of what your next parenthesis is going to contain. Does everyone follow that? So, the coefficient, this first coefficient, the exponent of that variable is always 1 less than what you started with. So this would be the coefficient of x squared, which would just leave us x squared. This would be the coefficient of x, and this would be our constant. Is everyone okay with that so far? So this will be 1 parenthesis, equals 0. Now we will write this as a parenthesis. This goes back to what I was doing here. This 2 is your r. To move this 2 over here, this will give us x minus 2 in parentheses. So x equals 2 is really x minus 2 in the parentheses. Does everyone follow that? Okay, now, x minus 2, we already know, if we set that equal to 0, we know that x minus 2 will give us x equals 2. We already knew that from the first problem. This second parenthesis here, we cannot factor that second parenthesis. So we will have to use the quadratic formula. So now, the quadratic formula, we know is Well, it looks as though I need another sheet of paper because I didn't leave myself much in the way of room. So, what I'm going to do is put this here. So, we will have our quadratic equation as x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, if we list our a, b, and c, do it like this. If we list our a, b, and c, our a would equal 1, our b would be 3, and our c would be 1. And that's based off of this parenthesis here. So, we could put this to the side for now, and we could substitute. We have the opposite of 3, plus or minus the square root of 3 squared, minus 4 times 1 times 1, all over 2 times 1. So we have x is equal to negative 3, plus or minus the square root of 9, and that'll be minus 4, all over 2. So it'll be negative 3 plus or minus the square root of 5, all over 2. So, after you factor this, your final answer would be x equals 2, and then it'll also be negative 3 plus or minus the square root of 5 all over 2. So that would be your final answer. So remember, we had to use the quadratic function to factor this out. Now, the reason why we had to do all of this, like I said before, our degree is 3. We were supposed to have 3 answers. We have 3 answers now. So now this has been completely factored. Does everyone follow that? All right, now, for number 2. Okay, we have this problem here. Now, I am going to say this because we covered this already. If you notice, this number 2 is the same as the number 2 over here. So we could go ahead and write this again like we did before. P over Q is equal to, it'll be negative 8 over 3, which will give us positive negative 1, positive negative 2, positive negative 4, positive negative 8, all over positive negative 1, and positive or negative 3. Now, when we do all of this, we would end up with, or just to write them all out, positive or negative 1, positive or negative 1/3, positive or negative 2, positive or negative 2/3, positive or negative 4, positive or negative 4/3, positive or negative 8, and positive or negative 8/3. Okay, now, these are all the potential zeros here, or potential solutions. But we know that our solution was only x equals negative 1 and also 2/3 from what we did before. Does everyone follow that so far? Okay, now, we need to do synthetic division. My question to you is this here. Which one of these should we use for synthetic division, the negative 1 or the 2/3? Okay, we could try the negative 1. So we'll do our divisor here of negative 1. The coefficients will be 3, 1, 10, 4, and negative 8. We'll bring down our 3. Negative 1 times 3 is negative 3. 1 minus 3 is negative 2. Negative 1 times negative 2 is 2. This will be 12. Negative 1 times 12 is a negative 12. This will give us negative 8. Negative 1 times negative 8 is 8. And we have nothing remaining. Or we have 0 remaining, I should say. Okay, so now, We have 3, -2, 12, and -8. All right, what is the degree of this equation here? What is the degree?
4.
4. Okay, now, if we wrote this out, what would be the highest degree of this parenthesis here if we wrote it out? 3. It'd be 3x to the third, right? And then remember, we have these two values here, correct? So wouldn't that give us a degree of 5? Because wouldn't this be x plus 1 and x minus 2/3? And then this would be 3x to the third. Wouldn't that give us a x to the 5th power? Yes? No? Maybe so?